Hi everyone, welcome to Code Management. So myself Kaustav Ghosh. Earlier video we have discussed about the profiles annotations. So we have covered like how you can manage when you will have to manage the local, the stage environment and production environment simultaneously. So if you have not checked it out, so just go to the playlist, the Spring Boot discussions, and there you can get such videos. We actually discuss the topics of Spring Boot, okay, the real life problems, how we will solve those. We discuss mainly those things. So today our main topic is transactional annotation. So that is a very great topic, and I tried to prepare it well. That's why you can understand the things, understand the problem, understand like how this transactional annotation uh, came into the picture. Okay, so like that. So like the other videos also, like my first motto is like what problem we faced, and to solve that, that annotation came. And the same way here also, I will first discuss about the problem, that the danger of concurrent access. Okay. So imagine you were building a banking application and there are two users, user A and user B, and both try to access their shared account at the exact same moment. So initial balance is $1,000 and request one came from user A and he tried to withdraw $500. So now he rate the balance as the $1,000 and check if our $500 is available. So it's yes. And now calculate the new balance, that is the $500. So updated balance is $500. Now, at the same point of time, the request 2 came through the user B and he tried to withdraw $300. Now he is also reading the balance as $1,000 because user A has not updated it yet. And he also checked like if $300 is available. So system gave him that yeah, it's available. So now the calculating the new balance 1,000 minus $300 is $700 and updated balance is $700. Now see how much data inconsistency is it? Like through like by user A, $500 has been withdrawn and user B is $300 withdrawn. So total withdrawn is $800. Now remain balance is $200, but updated it as a $700. So the account should be $200. So this is severe data inconsistency, right? Caused by the race condition in a critical section. So that's the problem of the concurrent access. Now the solution is transactions and the ACID properties. Okay, so for a system to be considered transactional, it must adhere to the ACID properties. But why? To prevent this nightmare problem, like we need a way to group these operations into a single indivisible unit of work. Okay, so this is where transactions came into picture. A transaction is a sequence of operations that are executed as a single all or nothing operation. Okay, so for a system to be considered transactional, it must actually adhere this acid properties. So what is the acid properties actually? That I'm going to discuss. So first of all, for A, it is coming as the atomicity. So atomicity means all or nothing, means ensures all operations within a transaction are completed successfully. If any operation fails, the entire transaction will get rolled back. Okay, so either all operations within the transaction succeed or none of them are applied. If one step fails, the entire transaction is undone, means rollback. Okay, so that is the atomicity. Next is the consistency. So consistency ensures the DB state before and after the transaction should be consistent only. So a transaction must transform the database from one valid state to another, and it cannot violate any database constraints or rules. Next is isolation. So what is isolation? It basically ensures that even if multiple transactions are running in parallel, they do not interfere with each other. All will be isolated. Okay, even they are concurrent. So next is durability. So durability ensures the committed transactions will never lost despite system failure or crash. So once a transaction is committed, its effects are permanent and will survive any subsequent system failure. So that is the durability. So we have discussed this what is atomicity, consistency, isolation, and durability. So that acid properties need to follow. Now, the transactional process. So I will discuss the pseudocode, but let's look this debit credit example what I have provided. So this is the classic money transfer problem. So now that marks the start of the unit of work. Then we are trying like performing the individual operations. Debit from account A. So big decimal balance A equals to account service dot get balance A. Account service dot update the balance, then the balance will be updated, then credit to account B. So here also we'll get the balance, and after that we are updating the balance. Okay, now if everything is successful, then make the change permanent, then commit. Otherwise we will catch the exceptions as well. If any operation fails, undo all change within the transaction and roll back, and probably read through or handle the error appropriately. And finally we will end up the transactions. So this is the cleanup or close resources. So this ensures that either both the debit and credit happen or neither happens. So that's the atomicity. Okay, so we never end up in a state where money has been debited but not credited. It will not be happened. Now next is like Spring Boot implementation. The through the transactional annotations, Spring Boot implements that one. So step one is we will add the dependency in the pom.xml, but we will add the Spring Boot starter data JPA. Okay, so Spring Boot leveraging the power of the Spring framework makes this entire process incredibly simple with the transactional annotation. So it declaratively manages your transactions, handling all the begin, commit, rollback. What I have discussed here, it is begin, then here the commit, and if not, then rollback. Okay. So here for standard Spring Boot application that interacts with a relational database, so you need to add the starter for the JDBC or JPA, which includes JDBC. So you know JPA and JDBC, right? So your JPA is on the interface, and for that interface we implement through Hibernate, and then it will connect with the JDBC. JDBC again it is the interface, and then we will have the driver class which will implement that one. So if you want to like discuss about the thing, so I can draw the picture in that way. So suppose your that is a JPA. So JPA is your interface, then it will connect with the Hibernate, right? Hibernate is our implementation. So in space of Hibernate we can have other as well, like Eclipse JPA, something like that. So next it is the JDBC actually. And next your drivers are there, like database driver like MySQL drivers or the PostgreSQL drivers. Okay, SQL or NoSQL drivers I can say. Okay, so that's the architecture actually. So here we need to like Spring Boot's auto configurations will detect the presence of the starters and a data source, and and set up the necessary transaction management bins automatically. So you don't typically need a separate dependency just for the transactions. Okay, we will just add these artifacts and group ID. Okay, then it will manage properly. Then activate the transaction management. So in your main application class, you need to use this enable transaction management annotations. It basically adds the transaction support. Okay. So when you will add, the transaction management will be activated. So next is apply the transactional annotation. So you can apply the transactional annotations via class level or the method level. So in the class level, it actually applies the transaction to all the public methods in that class. So this is a good way to set a default transactional behavior for the entire service. So in the class level, so it is suppose account service, and on top of this class, we have said this transactional annotations that is default for all public methods. Okay, and inside that you have the create account method. Inside that you will pass whatever you want to. Now, next is the method level. So method level actually overrides any class level setting for that specific method or provides transactional behavior to that particular method alone if no class level annotation is present. So this is where you would define your more specific transaction rules. So here we have the transfer service, and inside that we were just auto-wearing this account service, and then we are defining a specific transactions for this method, and this transfer money on top of this method, we are just specifying the transactional annotations, and we have set the propagations as propagation dot required, and isolations also we are defining as isolation dot default. Okay, so that one concerning point. So when we will specify the method level transactional annotation, we can specify the uh, propagations or the isolations. Okay, and the class label is the default type, and it will be applied for public methods actually. Okay, so here the debit from credit to B, and the commit or rollback logic is handled automatically. Okay, so here you have seen that propagation dot required we have added. So in next lecture we will discuss more about like the other propagations. There are more propagations, right? Like required, new, supports, not supported, mandatory, never, nested, and isolations you are seeing this is the default level. So other isolations are there like read uncommitted, read committed, repeatable read, serializable, those things. Okay. Now the magic behind the scene AOP and the around advice. So how does a single annotation replace all that try catch commit rollback boilerplate? So the answer is like AOP, aspect oriented programming. So when Spring finds the transactional annotation on a method or a class level, so it doesn't call the actual method directly. So instead it creates a proxy for your class. So this proxy basically intercepts calls to your transactional methods, and the point cut expression matches the transactional annotations, and this triggers an around type advice in AOP. Around advice wraps the execution of the target method. So the proxy advice logic you can see here. So before calling your method, this is the status actually. So you will get the transactions. So here the transaction begins, and then in the try block we will call our actual method. So our actual service method is being called, and after successful executions we will commit that, and if it is not, then in the catch block we are just doing the rollback and then rethrowing, so you can handle it externally. So if you want to get the flow properly, so so first of all, like Spring actually finds the transactional annotations. Okay, Spring will find that on a method or a class level, then it does not call the actual method. What it does, it will create what? Proxy. Your proxy will be created. Okay, and does not call the actual method, so it proxy will be created, and this proxy intercept calls to your transactional method, right? Now, then The point cut expression matches the transactional annotation. Okay, the point cut expression matches the transactional annotations, and it will trigger the around type of advice. Triggers around type of advice. Okay, in AOP. Okay, so around type advice wraps the executions of the target method. Okay, so that's the process. Okay, now in the next lecture we will discuss more. Okay, so this is how Spring Boot gracefully manages the entire transactional life cycle. Okay, so it helps to focus you on the your business logic. Okay, we need not to concentrate on this boilerplate codes. Okay, so that's all. Do like, share, and subscribe as much as possible for motivating me. Okay, then we will discuss more and more on top of this Spring Boot. Okay, thank you, everyone.